Swayam Prabha. Digital India. Educated India.
Welcome back, my dear students. This is the 26th class for project management. So, we are continuing with interest rate, fixed interest rate, variable interest rate and then net present value. So, we will consider the concept of fixed discounting rate, which is slide number 305. So, as written down in slide 305, a fixed discounting interest rate is a rate where the interest rate does not fluctuate during the fixed rate period of the loan. If you remember, I consider R as fixed and in the table also. This allows for accurate prediction of the future payments. Concept of variable interest rate is when the interest rate changed depending on the economic conditions. So, it changes accordingly. A fixed discounting rate is based on the assumption about the average discounting rate over the fixed interest rate period. For example, when the interest rate is historically low, fixed rates are normally higher than the variable rates, and conversely, when interest rates are historically high, lenders normally offer a discount to the borrowers to fix the interest rate over the period. So, this fixed and changing interest rate, if you see in the international and in this domestic market. So, in the international, you may have heard about LIBID and LIBOR, which is London Interbank Interest Rates, offer rate and the bid rate, LIBID and LIBOR. Similarly, when you come to the concept of the Indian market, you have the MyBid and the MyBor, which is the Mumbai Interbank deposit rate and the offer rate, bid rate and the offer rate. So, that means what is the interest rate based on which money is exchanged between the banks. If I go, not for the normal public, generally based on which banks offer to other banks money or take money and how the interest rates are calculated. So, there are other factors also come into the picture, but it is basically concept of demand and supply. So, again the fixed I am using the same formula as I have done it for the concept of interest rate, just discuss at the fag end last 5-6 minutes for the last lecture. So, the net present value, which is at t is equal to 0, is calculated based on the fact that C0, C1 till C suffix t are the so called net value of the input or output, and R, which is the interest rate, is fixed, and for the first term it is 1 plus R to the power 0, and correspondingly for the second term is 1 plus R to the power 1 till the last term it is 1 plus R to the power t. So, these are the discounting factors which are coming into the picture to order to find out the present value of the amount of money, which is C1 after time period 1, C2 after time period 2, and the last value being C suffix t after time period capital T. Net present value, if I consider the input and the outputs, input means the amount of money which is coming in, and output being the amount of money which is going out. So, again if I consider as the revenue and the cost, it is given with a negative value, which is minus C0, minus C1, minus C2 corresponding values, and the revenues are given as R0, the suffix values. So, then R1, R2 till the last value, which is RT, and if you see the interest rate in both these cases are the same, which is R, which may not be true, as I mentioned the concept that if you go to the bank, take a loan and go to the bank and deposit money, or say for example, when you go to the SBI's foreign exchange counter, you go and deposit euros, or you go and basically try to take some euros out for your travel abroad or vacation abroad, whatever it is. The variable interest rate, again the concept is the same, only the values of the interest rate change are. So, in the same concept, For the first one is variable interest rate. So, C0, C1, C2 are the net input output values calculated, provided they are at the same point of time, and the interest rates are variable being R0, R1, R2 till RT, and the net present value if I want to find out based on the fact that the interest rate for the inputs and outputs, demand and supply are different. So, here you see R suffix 0 comma C for the outflows, or R 0 comma suffix 0 comma R for the inflows. So, based on that you calculate the value minus C 0, then minus C 1. So, the minus sign is here, then minus C t till the last term, and these R zeros are R is plus R 0 plus R 1 till the last term, which is R t. Now, the next concept we will cover is the internal rate of return, IRR. The internal rate of return is used to measure the profitability of the potential project investment. So, IRR is a discounted rate that makes the net present value of all the cash flows from a particular project equal to 0. So, I want to find out that particular interest rate which will make the net flow of money input and output as on today, which is time t is equal to 0, as 0. Because based on that I want to find out that what should be my quantum of different values of inflow and outflow which is going to happen at some future point of time, such that considering the input cost or the sunk cost or the fixed cost whichever I am doing today would balance in such a way that I neither make a profit nor make a loss. So, obviously, then the interest rate based on which I want to try to find out the profitability or the loss of the project would be based on the fact that whether the value is more or less than the value of IRR. So, the formulas is net present value has to be 0. So, obviously, if you see the in the 307th slide on the left hand side, it was on both the equality equations, it was net present value suffix t is equal to 0, that is as of today. So, that value becomes 0 as pointed out here, and IRR is the interest rate. So, what I have is that I0 is the so called investment at time t is equal to 0 divided by 1 plus IRR to the power 0, because that is the time frame is 0. Then for the second time frame or time period you have I1 divided by 1 plus IRR to the power 1, and correspondingly the last value is IT, I suffix capital T divided by I1 plus IRR to the suffix capital T. So, this value is 0. So, what you do is that you know I0, I1, I2 till I capital T. Only thing needs to be calculated is IRR. You use some simple mathematical methods to find out the value of IRR. Now, where IRR is important? If your actual interest rate based on which you are going to do your calculation is more than IRR. So, if you consider here, if the value is more, then the denominators are more. If the denominators are more, then obviously it would mean that it would not make any much sense for you to basically go into the invest. So, if this net present value would basically be less, because each term is reducing. If each term is reducing, then it will mean that the right hand, the whole sum of all the values on the left hand side would be much less. If IRR is more, which means that that it would have an effect such that based on the fact making an investment decision has to be relooked into in order to make the decision for the project justifiable, whether it makes a profit or a loss. So, now we will go into calculating, even though it is not directly related to the project concept as such, we will try to find out how the interest rate for the project management can be calculated. So, consider the n year 0 rate or the n year 0 nth year spot rates. So, these are of importance for us and we want to calculate it. So, interest rate earned on an investment of a project that starts today and n years from now. N years, again I am telling you that n years need not be integers, it can be 3 years 4 months or 4 years 15 days. So, whatever the base calculation is. So, note for this concept to find out the n year 0 rate, n years spot rate, whatever calculation you want to do, you are considering that intermediate there are no payments. So, the values of I 0, I 1, I 2, I 3 or C 0, C 1, C 2, C 3 or R 1, R 2, R 3, R 4, all these values are not coming to the picture. So, only you have I suffix t or C suffix t or R suffix t, based on that you will try to calculate the interest rate. So, obviously, it would mean that once you do the first step of calculation, any intermediate payments or intermediate calculations for the interest rate can be done accordingly. So, that is not difficult. Once you find out the interest rate for projects for which there are no intermittent payments, you can find out for intermittent payments how you will do your calculation. We will come to that within few minutes. So, project cost and the yield from the project. So, we want to find out what is the return. So, how do you calculate the price of a project? If time to maturity is T years and it pays semi-annual or quarterly or monthly interest. So, there if you remember, I did mention interest rate is calculated on a per annum basis, but the payment can either happen quarterly or semi-annually, on a daily basis, on a weekly basis, whatever it is. So, remember the 0 rate for different maturities used to calculate the value of the projects at different times are not equal. So, 0 rates may be different for different time periods, and rightly pointed out in the discussion in the last 10-15 minutes. The yield from the project bearing some payback is the discounted rate that equals the cash flows of the project to its market value. So, basically the market value is the value based on which the demand and supply would be calculated. So, market value being low or high would basically have a sense of whether the interest rate is low and high, based on which you can do your calculations for the project returns accordingly. So, consider the project pricing, that means I want to find out the price of the project and the 0 interest rate continuous compounding are given. So, continuous compounding concepts I assume all the students are aware of that, based on the fact I am proceeding. So, maturities are given in years. So, if you see this 0.5, it means time period of 6 months. If you see the third value, it is 1.5, it means 1 year and 6 months. So, this first column are the maturity in years, half a year, 1 year, 1.5 year, 2 years, and the 0 interest rates are calculated for 6 months, it is 5%. For a duration from not from the 6th month to the 1 year period, is from the 0th month to the 1 year period. So, if the maturity in years are given starting at January 2017, 6 months would be the middle of 2017, then 1 year would be end of 2017, this 1.5 year would be middle of 2018, and 2 years would be end of 2018. And correspondingly the 5% which you have is the interest rate calculated for the time period from January 2017 till middle of 2017. If I see 5.8, it basically means starting from January 2017 till end of 2017. When I come to 6.4, it means starting from the January 2017 till middle of 2018. And the last one 6.8 is basically starting January 2017 till end of 2018. So, these are for the time period starting at t is equal to 0, not intermittent. So, intermittents are not there, we need to find it out. So, consider where we have a 2-year project with an initial value of Indian rupees 100 crores, and it provides a rate of 6% per annum. So, now see here, this 6% per annum, as I mentioned, it is calculated on per annum basis, and in the last slide which we discussed, which is slide number 311, we did mention that interest rate is calculated on a continuously compounded basis. So, with the return from the project being, but the payment is being done on a semi-annual basis. So, there are 3 important things. Number 1, per annum calculation, it is continuous compounded way of calculating, and the payment happening on a semi-annual basis. So, it could have been either per annum remains calculations remains as it is, continuous compounding can be simple interest, can be continuous the compounding concept can be compounding concept, whatever, monthly, yearly, quarterly, whatever it is. and the paybacks are given here semi-annually. It can be on a quarterly basis, on a weekly basis, whatever it is. So, we are need to find out the project price. So, before I go to the next slide, I will again try to draw the people who are doing this course their attention on 3 important facts: per annum one, whether it is calculated on a continuous compounding basis or simple interest and other concepts. And the third point is that payment is happening on a semi-annual basis. It can be quarterly, it can be yearly, whatever it is. So, these 3 concepts, as I continue doing the problem, I will highlight it time and again. So, to calculate the project price, we can discount each cash flow to the appropriate 0 rate. So, let us consider the first factor. So, 6 was the interest rate being paid on an amount on a semi-annual basis. So, if it is paid on a semi-annual basis, so there would be 2 payments on a yearly basis. So, hence it is 6 by 2 being paid for the time period 6 months. So, if I consider the table, the first table which I had, for a 6-month period the interest rate was 5%. So, here if you see, using the concept of continuous compounding, which basically means e to the power whatever it is, and the negative value means, because I am trying to find out the time value of money as of now. So, this 0.05 is coming from the table, which is the interest rate for a 0 interest rate for a time period of 6 months, and this 0.5 is the time period which is half a year or 6 months, and this 6 by 2 is the semi-annual concept of trying to pay back the interest. So, if it was being paid quarterly, so considering the fact that the year would basically have quarters based on the calculation, there the value 6 would be divided accordingly. If it was mentioned that it was being paid on a monthly basis, then in that case 6 would be divided by 12. But the values of 5%, which is the first term here, or the year which is half a year, those remain the same. If I go to the next term, again semi-annual means 6 by 2. The interest rate for a 1 year period is given as 0.058, which is 5.8%, and the time period if you see is 1.0, which is 1 year. This negative sign, as I mentioned, is basically the time value calculated as of now. Similarly, if you go to the third term, after 1.5 years, the semi-annual concept remains true, hence it is 6 by 2, and e to the power minus, obviously minus, we know why it is minus. The interest rate is given as 6.4%, hence it is 0.064, and the time frame is 1.5 years, which is 1.5. And the last term, if you see, it consists of 2 terms inside the bracket. One is the interest rate 6 by 2, and one is the principal amount, which was 100 crores. So, these values have to be brought to the fact that what is the price of those 2, principal amount being paid along with the interest rate being paid, what is the time value of that as of now. So, as of now, hence it is e to the power minus, the interest rate as given in the table is 6.8%, time period is 2 years, and hence it is 2.0. Now, so this would basically give me the calculations based on which I can find out that what is the value of the project. Now, I want to find out the yield of the project. So, yield has something to do with the concept of IRRs. So, the yield of the project is the discounted rate, something to do, it is not exactly similar to IRR. So, yield of the project is the discount rate that makes the present value of the cash flow of the project equal to the market price of the project. Suppose that the market price of the bond or the project in our example equals to its theoretical price as calculated, and consider the yield from the project is y is given by solving this equation. This equation does not look very intimidating, it is very simple. So, if you consider the last equation we have solved, which was in the 313th one. So, the term on to the right of the equality sign, this part is exactly the same. So, this part I will highlight is exactly the same what we did. 6 by 2, this is on the semi annual one, these 0.050 or 0.058 or 0.064 or 0.068 are the interest rate based on the calculation of the 0 rate for half a year, 1 year, 1.5 years and 2 years, and the time frames are given as 0.5, 1.0, 1.52. So, this has to be equated to a certain value based on the fact that those calculations are calculated using the yield of the project. So, which is y. So, if y is to be found out, we again do the same calculation for the equation which I am just highlighting now, but only based on the fact that the semi-annual fact remains the same, which is 6 by 2, time frame remains the same, but the interest rate based on which we recalculate and try to find out the yield is y. So, once we know y is basically the so called return concept based on which we can understand how good or bad the project is. So, we can use Newton-Raphson method, Runge-Kutta method and so on and so forth to find out the value of y. So, start with the value of x 0, which is the basic concept in the Newton-Raphson or any iterative method. Use successively a value of x 1, x 2, x 3, which is the consequent value of x based on the fact what is the rate of change of the function happening, in which direction it is increasing and decreasing, till you are able to find out using some iterative numbers the exact value or some near value based on the fact that it will give you a quite a good estimate of y, and you can find out what is the yield of the project. Now, we will come to the concept of par value. So, the par value what we have done is exactly the same here. So, the par yield for a certain maturity is the rate that causes the project price to equal its face value. So, the face value what we have done is, so in the first instant IRR was when you put the net present value as 0. Then in the case of the yield of the project, we try to find out that what is the value of y based on which the value, considering its yield value is true or considering the actual interest rates are true, what is the value of y such that it exactly balances, and based on that you find out y. Now, the par yield basically is some interest rate based on the fact that it will exactly equal the face value or when the project started. So, I am taking the face value as equal to the actual investment of 100 crores which you want to do. So, here again the concepts or the information set remains the same. So, it is semi-annual payment, the 0 interest rates are given as 5%, 5.8%, 6.4% and 6.8%, time period being half a month, 1 year, 1.5 year and 2 years. And if you see the calculation, the first term is based on the fact that C is the par yield, and then you find out what is the present value of that money. Hence, it is minus e to the power minus C, and then this term. Then if you want to find out the present value of the money for the amount of payment which is happening after 1 year. So, this is the second term which I am now highlighting, and if you consider what is the amount of payment or the based on the fact what is the present value of that amount after 1.5 years, the third term is the value, and corresponding to the fact when the overall project ends after 2 years. So, there would be two terms, one would be based on the fact that is 100 crores and another is the 6% whatever you received, that or the C value, sorry, the C value of the par value which you received, based on it is basically being divided on a semi-annual basis, you find it out. So, that term has to be brought back as of now, which is today. Hence, it is multiplied by the value of e to the power minus 0.068 into 2, and that is equated to 100 crores, and based on that you find out C. So, the par yield considering the concept of par yield further, in general if m is the number of project payments per year where each project payment is of each value being equal. So, D is the present value of Indian rupees in 1 received at maturity, and A is the present value of an annuity of Indian rupee 1 on each coupon. So, what I need to find out is that if I equate, what you will see is two things. D is the present value of Indian rupees received in maturity. So, what you will do is that you try to find out the present value of two terms. One is the present value of the principal amount whenever it is paid, plus the overall amount based on the fact that what are the intermittent payments which had happened, and you want to find out the present value of that. In case RC is the continuous, R suffix C is the continuous compounding interest rate, RM is the equivalent rate with compounding n number of times in a year, n is the number of years, and m is the number of compounding happening for RM. So, if you remember, I did mention the interest rate are calculated per annum basis. The interest rate type of calculations are based on the fact they are compounding. So, the compounding can happen at quarterly basis, on a daily basis, on a weekly basis, or on a continuous compounding basis. And number 3 is what is the payback concept. So, there are two things. One is how the interest rate are being calculated, so based on that I have to return the money, and also is that what is the time frame or how many times I get back the money, consider I have invested some amount of money in some project. So, what is the time frame? Is it 6-month basis, is it quarterly basis, whatever it is, that would come into the picture. So, in this formula, if you read the fourth bullet point, m means the number of times the compounding is happening for RM, and RM is the equivalent rate with compounding m number of times per annum. So, consider the zero curve. So, and you have the project principal amount in rupees, it is given in the first column, time to maturity is given as 1/4 of a year, half a year, 1 year, 1.5 years which is 1 year 6 months, and the last factor is 2 years. And the annual coupons means the amount of money of payment which is happening, and for the first 3 instances it is 0, and for the second last and the last one, the coupons or the amounts being paid are 8 and 2. They are arbitrary values in order to make you understand, and the project price is calculated based on the fact it is 97.5 for 1/4 of a year till the last value which is 101.6 for a 2-year period. So, we assume, given as per the concept, that half of the stated coupon is assumed to be paid every 6 months, that is half a half year duration. So, let us go through the calculation so slowly. Now, if you see the first part, it says it is on a 1/4 of a year. So, 1/4 of a year would be 3 months. So, if I consider the overall the face value of so called project is 100 and 97.5 is the value, hence 2.5 can be earned on an investment of 97.5 during the 3-month period, because the time frame was 0.25. So, this 3-month rate would be about, because 3 months means it in a year there will be 4 times. So, it will be 4 multiplied by 2.5 divided by 97.5. So, 2.5 I am getting based on what? 97.5. How many times? Once in 3-month period. How many 3-month periods are there in a year? 4 times, hence it is 4 multiplied by 2.5 divided by 97.5, or the interest rate is 10.275 with the compounding concept happening on a quarterly basis. Why? Because this 0.25, if we are basically extend on a yearly basis, it will be 4 number of times, hence the quarters are 4 in number for a year. So, 10.256 with the quarterly compounding concept, which when converted into continuous compounding concept using the formula which I just discussed, it will be 10.127. So, for the first instance, when the value of the project was given as 97.5 and the actual value was 100, and you were able to find out what is the so called efficiency of the returns, and how many times the returns were paid in a quarter, 1 quarter, 2 quarter, 3 quarter, 4 quarters. So, there were 4 quarters. So, if it converted on a per annum basis, continuously compounded concept, the value comes out to be 10.127. So, with this I will close this lecture and continue with the discussion of the concept of bootstrapping and the zero curve, how you can find out and utilize those concepts in the project management sense. Thank you very much. Have a nice day.